Good morning, class. Today we're going to talk about the key characteristics of quadratic equations. So previously we were talking about linear functions. We were creating them, we were graphing them, and we talked about their key characteristics. Today we're going to describe those properties and key characteristics, but for a quadratic function instead. Tomorrow we're going to start graphing quadratic equations using the key characteristics that we're going to learn today. All right, so what do you remember about the key characteristics of linear functions? If you're completely unsure, that's okay. You to see here. B, if you need a refresher, you might remember doing it, but you don't remember exactly what they are. Or A, you can tell me about some key characteristics of linear functions. X-intercept, Y-intercept, whatever you may remember. So you guys have 3 seconds to do this. So at this point, once I got some student feedback, I would check to see how many students actually remembered what we went over and ask those students what they did remember. If they kind of remembered a little bit, I would obtain their feedback to see what they did remember as well. And then my students who are completely unsure, this would be their opportunity to refer to the anchor chart I provided them last week to check in with those reminders. So the first reminder I'm giving everyone, we're going to talk about positive slope and negative slope. Remember that a positive slope is when we're going up. So that line goes up from left to right, and those y values are increasing as the x values are increasing. So we're going up and to the right. Now, the negative slope, the y values are decreasing, but those x values are still increasing. So remember, we're going down, and we're still going to go to the right. Negative slope is when that line goes down from left to right. Another reminder we need to talk about are the intercepts, what they are and what they look like on a graph. So whenever we are talking about the x-intercept, that's when we're crossing that horizon line, and the x-intercept is where we cross that horizon line and that point only. So if we're looking from the origin here, this x-intercept, we're going to the right 3, up, down 0. So this ordered pair would be 3, 0, and that would be our x-intercept. Now, for a y-intercept, you need to think about columns or anything vertical. So y-intercept is where we cross that vertical axis, that y-axis, and that ordered pair would be 0, negative 5, because look, we're not going to the left or right any, but we're going down 5. So left or right 0, then down 5. So 0, negative 5. So the ordered pair for a y-intercept is always 0, then a y value. All right, so to get started with vocabulary, if you guys have trouble with anything, make sure that you refer back to that anchor chart that I provided you at the beginning of the lesson that goes over all this vocabulary as well. So first off, today we're talking about quadratic functions. Well, what is that? It's a function that can be written in standard form with the values y equals ax squared plus bx plus c, where a is not equal to 0. So a good question may be, why can't a be 0? Well, what is bx plus c? What kind of equation would bx plus c make? We just had this last week, so anything with x to the first as your highest degree of x is going to be a linear function. So if we have bx plus c, that's just going to create another line, but this x squared term is what makes a quadratic, and it's going to give us a very interesting shape. So a can't be 0 because what is 0 times anything if we have 0x squared? Well, right, it's just going to turn to 0, and that would leave us with that linear equation. So what you might be wondering is, okay, we're talking about quadratics, but what does this look like if it's not a line? So quadratic equations actually create a really interesting shape. So look at this one and tell me, what does this look like? What do you think this looks like? Put it in your notes. Okay? With 1x squared, so when this a value is 1, look at the graph. We have this positive U shape. So instead of us going straight through like a line, notice that we come back. Now, what if we change it to a negative? Okay? Write your observations in your notes. When we change this a value to a negative, what happened to the shape? Can you think of an example where you might have seen this shape in a real life situation? Okay, write this in your notes. Think of an example and write it down. Here's a first example. Think about this dolphin jumping in the air, or a slinky shape, or any kind of building, a bridge, lots of architecture. Trajectory of gravity. So as you throw a ball, notice the shape it would make. And one of my favorites, let's look at McDonald's. Notice that if we did half of this M right here, the shape it makes. So, properties of quadratics. The shape that it makes is called a parabola, and that's in the form of a U. So you guys might have written that down. In the form of a U, which opens either up or down. So it'll open down if that A value is negative. So look at y equals negative x squared. And notice at this vertex point. A vertex is a maximum or minimum point of the parabola. And what I want you to think about with the vertex is imagine that you're riding this like a roller coaster. So you're a little guy over here on the left and you're going to ride this roller coaster, okay? Once you hit the peak of the roller coaster, like when you get to the top of a roller coaster, what happens? Well, we get to the top and then we're going to come back down. So we're going to change direction, and that point, that maximum point, is called the vertex. Now look at this one to the right, y equals x squared. If we're riding this parabola like a roller coaster, so starting from the left and working our way to the right, we're going to go down. And what's going to happen at this point? Right, once we're going down, we're going to change direction and start going up again. So this minimum value is also the vertex. So if it faces down, our vertex is at the top. That makes it a maximum point. And if the parabola faces up, the vertex is at the bottom, which makes it a minimum point. Now, that direction of the parabola is completely dependent upon this A value. So if A is positive, then that graph will go up. And this will create a smiley face. Yay, we're happy, we're positive. And it will concave up. Formal definition. Okay, so check your anchor chart there for that vocabulary term. If A is negative, then the graph opens down, shad face, so concaves down, okay? A positive, happy. Negative, A negative, sad, concaves down, okay? All right. The axis of symmetry, that's that line that passes through the vertex at which the parabola is symmetric. Okay, what does that mean? So I need you to imagine yourself folding a sheet of paper completely even, all right? And notice that when you fold your paper completely and even, you have this kind of like halfway folding point, right? It's this invisible line, but you know it is completely symmetric on both sides. That would be our axis of symmetry in theory for a parabola. So it's this invisible line that has the symmetrical, or is completely symmetric for the vertex and this parabola. So look, it goes directly through the middle. It's also located at x equals to the same x value as the vertex. So once we find our vertex, it's going to be very easy to find this axis of symmetry. Where would this vertex be located? If we look from the origin, we'd go to the right 2, up, down 0. So we'd have a vertex at 2, 0. And then our axis of symmetry is equal to x equals to 2. So same x value as the vertex. Let's do an example. So our first example, describing this vertex. So if we look for our vertex from the origin, we're going to the right 1 and then down 4. So that vertex would be located at 1, negative 4. Our axis of symmetry, look at the x coordinate of your vertex. So our axis of symmetry would be located at x equals to 1. Now, is it a minimum or a maximum? If we were riding this parabola like a roller coaster, notice that we're going down and the parabola would be facing up. Our vertex is where? It's at the bottom. So this would make it a minimum point. The x-intercepts are located at the x values of -1 and 3. So at the points -1, 0 and 3, 0. Our y-intercept would be located at the point 0, -3. Okay, so make sure you get all this down. We're going to practice together now. All right, so help me describe the key features of this parabola. At this point, this is where I would ask my students, what do they see first? Do they see the vertex, the axis of symmetry, minimum or maximum, or the x or y intercepts? More than likely, I would encourage my not proficient students to start with x and y intercepts, these familiar topics that they learned in the last lesson, and then working our way to vertex, then axis of symmetry, and minimum and maximum points. Then in the next topic and next question, I'm going to ask my students individually to describe the polynomial graph using vocabulary from this lesson. So they would have a picture of a parabola given, and they would have to share their thoughts individually. It would pop up on the screen, so I'd be able to quickly identify what they remembered first based on the order they give me and their understanding of vertex and axis of symmetry. I would encourage my students to use the terms that they've learned previously in their description and refer to the anchor chart in case they forgot some of this vocabulary, vertex and axis of symmetry. I would also at this point facilitate conversation with my students who are struggling with their reading comprehension to refer again back to that anchor chart to use this vocabulary and kind of aid them in their explanation and see if that helps as well. Now, if my students are struggling with these descriptions on their own after having the guided practice, what I would refer to them to do is a Desmos activity that will go over the vocabulary again. We're also going to have this last poll question after they go through this. How confident do you feel about describing the key characteristics of a quadratic graph? I got this, I need a little more time or help, or I'm totally lost still. This would be a good time for me to know which students need additional help. If they need more time, then we'll go over this a little bit further with more examples. I can bring up a whiteboard where I can explain a few more problems with them and graph a few more parabolas. And if they're totally lost, then I'm still going to help them with these problems and encourage them to also refer back to that anchor chart with the Desmos activity. And if they got it, then I'm going to go ahead and let them move on. In this Desmos activity, they're going to review vocabulary again and interact with the Desmos activity in order to determine how different parabolas are similar or different. And I would start asking questions like, what does the vertex tell us? How do we know whether it's going up or down? And trying to use probing questions in order to reinforce the vocabulary and get them up to speed. Thank you guys for your time. And if you have any further questions, feel free to reach out at any point. Thank you.